Hey guys, welcome to what'll be the last video in our Let's Make a Game series, where we're going to make a game like Flappy Bird. In this video, really what we want to do is tie everything together in a game manager so that we have the concept of state. Right now, and I'll run the game right now, and what you'll see is it just immediately throws us into the game, and even though we can't die yet, there's no actual main menu screen or game over screen or anything like that. So to achieve this, what we'll want to do is have a game manager that'll track the state we're in and then push us in and out of states based on what's going on in the game. So really what'll happen is right now we have everything here in our main method, and we set everything up, and then we have this infinite loop where we just end up playing the game. All of this will have to get moved out to some new method in some new class. So let's create our new game manager. There we go. Alright, cool. We have a game manager. And in here, move this thing around. In here, we're going to want to know about engine, sprite, flapper, pipe manager, all that stuff. And actually, just taking a look here, the only reason we care about pipe here instead of pipe manager is because we want to call the initialize method on pipe. Really, the pipe manager should do that. That's what it's there for. It's there to manage everything related to pipes. So let's throw that in here. So it'll now when we initialize the pipe manager, it will initialize the pipe itself and then go ahead and create one. So that way we can bring that out of Twitch, and then eventually it'll bring it out of Game Manager as well. And then this input manager as well, right now it takes a reference to our player, which is a flapper, and all it does is check the key or the button press and then calls flap on the flapper. This is a little too much. I don't think we need an input manager class at all, really, because first of all, this is a really easy check, so we can just throw that into flapper directly, and it'll actually make things easier when we start dealing with input based on state. So let's bring this check out. Put it in flapper directly. So it was in the update, and we were updating it before we update the flapper. So we'll put it right here. Oh yeah, we'll need. Obviously, this is no longer that, and then keyboard and mouse. There we go. So we'll check, and we can actually put this in its own method as well. We can do private method for this. So handle input, and the reason we do private is so that nobody else can tell flapper when it should handle input. It will decide when it wants to do it, basically. Oops. There we go. So if you press space or left button, it will actually call flap on itself, and we're going to call handle input on the update. So we should be able to see that. Yeah, and I guess so. Input manager we don't need at all anymore. We should remove it, and we'll have everything that needs to handle input handle it itself. So item manager or input managers are sometimes useful depending on the situation. In our case, because really we only care about this input and probably one more input to toggle between states in Game Manager. We really don't need anything like that. So if we go back to Twitch, we don't need that anymore. This doesn't exist anymore. And don't need to pull that either. So now we'll handle input here, and everything else should just fall into place. Yep, and that's click and space. Cool. Oh yeah, and one more thing, we can't. So because we're in an infinite loop, I can't actually click this window. It doesn't close it, and I can't, I would like to escape in order to quit the game. So we can add that when we port everything over to Game Manager. In fact, we should do that now. So For GameManager, we'll need to know what an engine is, what a sprite is, both of the inputs. Yeah, all of this needs to come over. And then there we go. And then GameManager, have a constructor, and it will have basically one of each, right? An engine. This sprite we just create locally in order to instantiate Flapper, so we don't actually need to keep that as a member variable out here. So we won't need that, but we'll need an engine. We'll make them pointers. Engine. Something like that. We'll have a Flapper, and we'll have a pipe manager. Cool. And then the reason we're using pointers here is because we care about the order in which we instantiate these. So if they were just objects, all their constructors would get called by the compiler or not by the compiler, but at runtime for us before we have any control over it. So something like pipe manager, which now has pipe initialize and creates a pipe within it, so this constructor will get called, and then it'll try to do these things before we call initialize on our engine. So it's things like that that we have to watch out for. So we'll just use pointers, and then we'll create them and delete them here. And then here, is where we'll want to bring basically most of this. So actually, let's just do this for now. This guy will need GameManager, and then so this will instantiate GameManager, which will instantiate everything it cares about, and then we'll have a start method that we'll create, which will start the game, and the actual core game loop will live in there. And then once we break out of that game loop, it means we're done and we want to close everything up, and then we'll return 0 and then we're done. So we'll come back over here, and then we'll need that start method. And then in here is where we're going to want to do these things. So engine equals new engine, and engine doesn't take anything, as you can see here. And then we'll call engine's initialize. Sprite, again, we didn't need member variable version of the sprite because it's fine the way it is. We only use it once here, except that instead of that being Flapper like that, we'll say mFlapper equals new Flapper, and I can pass in that test sprite. And then mPipe manager equals new pipe manager. And then we're done. Okay. And then now in the while true, we'll have our engine and Flapper, and pipe manager. And these are all okay. And yeah, that's right. This takes another reference to our Flapper, so we can just dereference this guy because he's a pointer now. And actually, that should be enough. Actually, let's move this where it's going to be. So that's our instantiation, and then void starts. And then in the start method that we get called from main, we'll go ahead and have our game loop. And I think that's everything ported over. Oh yeah, and then we'll want to make sure that we say engine or want to delete everything and clean up, and then everything's done. So let's try to run that. And yeah, everything still works properly, which is great. So we're basically, now we've ported everything over to our game manager, so now we have a little bit more control over how we want to split up the states and everything like that. So yeah, I guess one of the things we'll need is different states. So let's go back here and let's create an enum class. We'll call it state, actually, it's fine. And then we'll have a start state, a gameplay, and a game over state. And then we'll have to keep track of our state here. And then we'll ensure that our state start. So I did go ahead and get two more images here, and I'll post the links to where I got them from below. A space to start ping and a game over ping, both of which have transparent backgrounds, I think they should. So we'll just overlay those over top of the game as necessary based on which state we're in. So actually, yeah, one of the things we can do now is this while true again is the fact that it's a while true is fine. We can here, we're updating the engine for sure. This stuff will only get updated in our gameplay state. So really what we want to do is have a switch statement here. There we go. So there's 3 states. If we are in the gameplay state, everything remains the same because we still want to do all that logic. And here it's good practice to have our default. And in this case, the default will just unhandled game state. And then we'll have mstate. And then, yeah, of course, mstate is an enum class, so we can statically cast that to an int. So it'll print out the int and then endl. So yeah, it's always good practice. If we ever add a new state and add logic elsewhere and forget to update this, then this will remind us that we need to update this. So now for start, I guess what I want is those 2 images. So we'll need 2 more sprites. And these don't have to be pointers because we don't care about that dependency there in terms of what needs to get instantiated first. So we'll call it mstart sprite and game over sprite. And then we can set them up just like this. We'll probably still want both of them to show up in the middle of the screen as well. Sprites probably aren't as big as our plane is, so we can probably not have to scale it, but we can do this. And instead of that, obviously we're doing start sprite, start space to start, and game over sprite is game over.ping. And then yeah, all we want to do is, so again, we want to update the engine every time, regardless of which state we're in, that's for sure. And then this begin and end render, we'll want to have here, except since we're not doing any logic yet, we just want to render, and we're just going to render our mstart sprite. There we go. So we're starting in the start state, and then we're in this while true, and then if we're in start, so it should render just our start sprite. Let's give that a shot. There we go. Press space to start. So you can see there's no gameplay going on in the background at all. I mean, we're not rendering it, so even if there was, you wouldn't be able to see it. But you can tell that we're not hitting this anyways because we're rendering this for sure. So nothing else is getting updated. What we will want though is the ability to be able to tell if we're pressing a button to move our states. Now when we're moving states though, we'll want to have a private method that does that for us. And the reason for that, and I mean it doesn't have to be private. In our case it will, because we know we don't want anybody else changing our state for us. Like Game Manager will handle changing its own state. So the reason we want a set state method is so we can do cleanup and setup or whatever when we're moving between states. So I can do mstate equals state, and then the value of mstate will be whatever state we're leaving from before that call, and then after this it'll be whatever state we're going into. So if I want to do some cleanup before I leave a state, I would, you know, have maybe a switch statement here or an if statement based on what it is. For now, let's just set the state because let's not worry about that right now. We'll probably come back to this, but when it's game over and we're resetting the state of the game, I mean. In this case, we'll just set it, and then here we can just do a simple check. So if and we have keyboard right in here. We have keyboard and mouse over here, which we don't need over here. We only need them in the CPP. So we can check if keyboard. So we'll say again space, right? So key down, GLFW key space, and we can also do click because you can click to play as well. So it's basically the same check and flapper. Button down. There we go. So now if we press space or the left mouse button, we can go ahead and call set state with gameplay. So then we'll go into the gameplay state, and then we should be able to start playing, and everything should render properly because we're out of this state. So let's go ahead and give that a shot, and we should be able to move from the first state to the second, right? So press space to start. I'll press space now, and there we go. Game starts, pipes, everything. That's pretty good. And then what we'll need now is the ability to leave the state when we die, right? So right now we don't do anything when we die. We just print that, and all those prints are coming from here. So what we can do is move this check down here, and then basically do the same thing. If it is colliding, then set state. Game over. We don't need to print anymore because we'll have visual feedback now. So what I expect to see, and then here we'll want to make sure we render game over sprite. And then let's add this check here again, and in this case we'll set it back to the start state. So now we have a way to loop through all the states basically if we keep dying. So let's run that, and then all right, we got a space start or a start state, and then we'll click, we'll play, and once I hit a pipe, it should send me to the game over state. And there you go. Oh yeah, we'll have to scale this one down. But there we go. So we changed state, and now if I click, I should be able to click back through to the start state, and then click back to the game. And okay, you can see it a single frame. So what's happening is we're going back into the gameplay state without having reset anything. So flapper is still in the same position, the pipes are still in the same position, so we're just colliding again, which is why you see a single frame. This will be easier to see if we actually render. There's no reason we can't render these, and actually it's probably better that way, because you'll want to see as a player, you'll want to see where you died or how close you were to that pipe. So we'll continue to render the flapper and the pipes, and then we'll render the game over spread over top, and let's scale that guy down probably by the same amount. Oops. Let's give that a shot. So if we break into this pipe, there we go. Oh, that's really nice. So you'll see game over, everything stops, and then you can tell that I'm still colliding into that pipe, and then I can click through to start. Nothing will get rendered, but you'll see how it's game over again, and if I click, it'll keep moving. Basically, we're only giving it one more frame, and then it's colliding again. So what we'll need, and that's kind of where this comes in, is we'll want to reset the state of the game if we're leaving game over state, basically. Or we can do it if we're entering the start state. That works as well. It doesn't really matter which one we pick. But basically what'll happen is we'll do something like flapper.reset, and then like this. And then obviously they don't exist. So for now, and obviously we have to check. So if mstate, so if we are now, yeah, so if mstate is state start. So if we are now in the start state, we'll want to reset everything. Nothing's getting drawn, so you won't see anything blink out or anything. Yeah, perfect. So now let's create those reset methods, and basically they'll just handle resetting positions, velocities, all that. So reset. And then so if we reset really what we want, and our position comes from the sprite, I think, right? Yeah, so we copy the sprite in to a local version, and then we pass, yeah, the size and the positions and all of that are passed in by reference, and this takes also pointers. Yeah, it takes pointers to those, and get pos returns pointers. Yeah, okay, so everything is driven by our sprite itself. So what we'll want to do is say sprite.setPos. All right, I have move to, right? Move to, and then we'll want to move it back to the center. Basically the same thing we did when we created it. Here, since we're actually actioning on that sprite, so we'll reset it to 0, 0, or well, to the middle of the screen, and then we can do rotate to 0. So we yeah, we'll reset the rotation. For now, let's try this. We don't need to do anything with the pipe manager, just so we can see the plane itself actually resetting. So we'll click through. I'm going to fall and hit that guy, and then click through it. Okay, so while we're resetting the position and rotation, we're not resetting the velocity. And remember, our velocity accumulates over time due to gravity, and until we flap, right? And then flap will just reset the velocity to a positive one with flat force. So really we'll want to do the same thing, but zero that out. So now, if we're coming down at a steep velocity there, it should basically just hover again, yeah. But you can see again, the pipes are still there. So it's okay. I think the flapper reset is pretty much done. Let's go back and create the pipe manager reset. And it'll be something similar. And in this case, really what we want to do is just delete all the pipes and then clear our pipe array. Oh, and we'll want to reset these guys as well, because they'll have moved, right? So total pipes will have to get reset, and then these actually get changed based on the speed if we're, the more pipes we're dealing with, or the more pipes that have been spawned. So we'll want to reset these to the starting values as well in reset. But really what we're doing is delete the pipes themselves, like the pointers, and then we can say pipes.clear. The reason we don't have to do like this pipes to delete stuff anymore is because here we want to delete a single pipe that is in the middle of a vector. So we can't do it when we're iterating in here, but because we know we want to get rid of everything, all we have to do is delete the pointers and then clear the entire array. So that's pretty good. And then yeah, we'll need to keep track of X start separation and Y start separation, and then again just set them up here. We'll set this to 100. Uh, 500, and then whoops. There we go. So we'll set them to the start values, and then we can, when we reset, we can do that again. X separation, X separation. cool. And then total pipes equals 0. And I think that's it for pipes as well. I think we're ready. I think we actually have a resettable game now. Let's see. So we'll go through. There, we see how we died. Click through. Empty. Okay. So we reset. Oh, yeah, of course. Our pipe manager, when we instantiate it, we do this and then we call create pipe. And create pipe is what actually starts the first pipe and gets the ball rolling, basically. So we'll need, since there's no pipe, the X separation thing is irrelevant, right? There's nothing in here, so nothing's going to happen. We need at least one pipe to kick everything off. So the reset will end off with create a pipe. So reset will basically act just like our constructor is acting. It'll clear everything up and then it'll create the pipe again, and then that should get things started. And then so there's the constructor creating that first pipe, and now here's us creating that first pipe. Yeah, that's great. And then there it is. Okay, awesome. And then we have a game over screen. Click through. Click through. Oh yeah, so one other thing we'll want to do is check the check to make sure the flapper doesn't go off the screen. We can't move left and right, but we can move up and down. So like for example here, I can click over this pipe and come back. So we don't want to be able to do that. So that's simple, basically, because in the gameplay state is where we're checking if we should move state. So is colliding, let's just say is dead. And then we can also check for position. So if I'm flapper, so we'll set it equal to checking the collision, and then we'll also check the position. If we're going off the screen on the top or the bottom, we'll set is dead to true, and then if is dead, we can set the state. Yep. So that's kind of a dummy check. Like we're not actually doing any kind of, you know, like, there we go. So there's dead, and there we go. Oh, there we go. Now we don't fall forever. Yeah, like we're not checking an actual rect here. Like we don't really need to. I don't mind having a little bit of leeway there, where like. Oh, that's funny. So I actually missed it on the way down, and then when I clicked on the way up, I hit it with my tail. But yeah, like things like that. Like you can be a little flexible like that. That's not a big deal. What I do notice though is that our hitbox is really big. So like it's possible to have it where the pipe will actually hit. I'm trying to get it now. There. So if the user sees this, obviously we're not going to be drawing the hitboxes around. So if the user sees that we're obviously not hitting from a sprite perspective, that's a pretty bad experience. So we can tighten that up. Really just on the Y. So that's our flappers, rigid body, bounding rect, right? So we're setting the size with this size offset, and then size offsets Y can probably go down to 3, I think. I think we can half what we had. See that? Yeah. Oh, that's much better. I mean, there's still a little bit of space just because of the sprite, like actually right there. Again, it's not hitting, but I mean, again, and that also depends on which image you're using. So for us, I think this is fine. It's much tighter. You can actually clip your wheels on the pipe, so that'll feel like close calls for the player. Like they'll be like, oh, that was so close, because yeah, again, you got that. Yeah, I like that. So we've got game state. That's pretty much really where I wanted to take this, right? Here now we actually have a game that you can play through. We could like we could make it harder. We could tweak the values. Oh yeah, and there, just clip that sprite, but not my hitbox. That feels pretty good. And in those cases, actually, we'll want to draw the flapper over top of the pipes. Let's do that. There we go. So if I do this, yeah, that looks better, I think, drawing it over top of the pipe. Yeah, so like this is really where I wanted to take the video, and I think this is a nice way to wrap up the series. We have a game where we can die, first of all. We can go back, reset it, start it, and then just keep playing it. A stretch goal would be to like add points and stuff, or we could even just add a timer to see how long you can stay alive for. And again, we can tweak the difficulty by just changing those separation values or the separation speed, changing the sprite we use now, or our hitbox now that it's so small, like might actually mean that our pipes can be much closer. Like right now, it's pretty trivial. And yeah, and then adding score and then just a score counter. We won't get to that in this series. Really, I think that's pretty trivial as well. Just adding points as the pipes cross the middle barrier, and the way you detect if it crosses is you check each pipe has a reference to its current position and its last position. So like really, we can do that actually really quick. So pipe manager, pipe itself will have its sprites, its position, and then another vector 3 of last pause. So its previous position, it's called pre-pause. And then we set up the pipe sprite. Here we set up this up. We set up the position here. We'll say pre-pause equals pause. So we want to make sure that it's always in sync. And then when we update, we'll update our positions. This will actually change our pause, right? Start pause. Because we passed that pause in. Actually, I guess we're passing the sprite's position directly in a reference to that. So really, this position's only it's actually not even really used. Move by, we update the position locally, and then we update. Yeah, it's okay. So we use it to move or to create the position we're gonna end up. Our sprite's gonna end up at. So let's see. Yeah, okay. So maybe then. Actually, it doesn't even matter. We can start it here. The point is, after we update, this will change our sprite's position. And then, before we update, we'll say pre-pause equals, let's say, right now we were using, this is the Y. Yeah, okay, so it's our actual X is what's changing. So we can say pre-pause equals top sprite get pause X. So we'll cache our position before our rigid bodies update our position, right? And then we're changing our positions based on our velocity. And then this way, what you can do is let's have pipe manager check or allow checking bool just crossed, or actually it shouldn't have that. Its update should do this. So as we're going through each pipe, and we can expose the previous position as well. And really we just need the X. This could be a float. Pause.x, pause.x, and then here. So now we can return the previous position, and then the previous position will be different than the current position at every interval because we cache it before we hit update. So it updates all the pipes. And then we check if it's gone, we delete it, and then if it's past the separation barrier, we create a pipe. And then here we can also check if pipes at I, get x, and that boundary for points will be the middle of the screen, right? So if the current x is less than engine's screen width divided by 2, and pipes at x, or pipes at i's previous position is greater still than engine's screen width. Basically, this allows us to check if we just crossed it, right? If we just crossed it, our current position will have gotten updated to be before or below the screen width's middle point. And then we can check if the previous loop, if we were on the other side of that barrier, right? Basically, and we've created now a score barrier. For now, let's just do, well, no, we can do pipe manager. Can keep track of points. We'll initialize points. To 0. And then the reset will also reset the points to 0. And then every time this happens, we score a point, so points plus plus. And then let's do it in the update as well. Let's just print out our points. So this should be enough now to keep track of that, and then we'll get spammed right now, which is fine. But as soon as that cross happens, there you go. Our points increases by 1 and no longer doesn't spam increase either. 0.2. There you go. Now we've got points, right? So it's pretty straightforward. What I don't really want to get into in this series is like drawing the score on the screen. Reason for that is GLFW doesn't provide that. It's just for windowing and all of that. So we'd need to use a separate library to do that. Kind of like I'm using Soil to load the images. And if you want to do it, by all means, the library I recommend would be FreeType, and I can post a link in the description as well. And with FreeType, you can like load TTF fonts and or for even FreeType fonts, and then render them to the screen. But again, we've got the points for our purposes. We've got the points working, and then if I die, reset, points you back to 0. Yeah, it's pretty good. So I'm not too concerned about drawing it on the screen, but I think this is a pretty solid game now. Like you can make it harder or whatever you like, and then you can challenge your friends or add to it, right? Like maybe you can add power-ups, right? So maybe you have a power-up that's invincibility. It'll let you take 1 hit and then it goes away. Or maybe it'll speed up the pipe speed, but also double the points you get if you keep things like that, right? Like again, at this point, all you're playing with is values. Pipe Manager handles it all for you. Like you can change the speeds there, you can change the separations there, you can change everything you want. And so you can have these, like Pipe Manager itself can also have states in terms of power-ups, or what kind of, like, are you in a hard level versus an easy level, and you can do all sorts of stuff with it. But I think this gives us a pretty good base. We have a game manager that handles our state. We have gameplay code that's handling input. Even it's rather simple, but I mean it gets the project started, right? And yeah, I'm happy with this. I think this is it. I think this is where we'll end up. I hope you guys enjoyed the series. I had a lot of fun making it. I know it took me a while, but we got done. And yeah, I hope that you guys do something with this. If you want to contribute to the GitHub, again, I'll post all this. If you want to pull request something, by all means, I'll get an email notification. We can take a look. And yeah, I hope this helped. If you guys have any questions, again, just write them down in the comments below. I'll try to answer as much as possible. And that's it. I'll see you guys next time.